Now let's talk about mappings. A mapping is a data structure that holds key-value pairs. It's similar to Python dictionaries, JavaScript objects, or Java hash maps. All keys and values must have the same type. The keys cannot be of types like mapping, dynamic array, enum, or struct. The values can be any type including mapping. Mappings are always saved in storage. A mapping is a state variable, and the mappings declared inside functions are also saved in storage. The biggest advantage of the mappings is that the lookup time is constant, no matter of size. This is in contrast with arrays that have a linear search time. So no matter how many elements we have inside a mapping, the search time is the same, is constant. A mapping is not iterable. We can't iterate through a mapping using a for loop. We can't, for example, get all keys or all values from the mapping. We only get a value if we input the right key. Keys are not saved into the mapping. A mapping is a hash table data structure, and to get a value from the mapping, we must provide the key. The key gets passed through a hashing function that outputs a predetermined index that returns the corresponding value from the mapping. If we want the value of an unexisting key, we get a default value. We don't get an error like in Python or in JavaScript. Let's see some examples in Remix Editor. If we want to declare a mapping state variable, we use the keyword mapping, and then between parentheses we specify the key type, let's say address. The keys are of type address. Then we have an arrow, so equals and greater than, and the type of the keys, let's say uint, unsigned integer. This value can be public or private, let's say public. Being a public variable, we can get the value from this mapping easier. And now the name of the mapping, let's say bids. This is how a mapping variable is declared. Now I create a function, let's say a function named bid. This function is payable. This means that this contract can hold an Ether balance, and an account can send Ether to my contract calling this function. The function is public, and inside this function I will add the address of the account that calls that function to my mapping variable. The address of the account that calls this function is found in variable named msg.sender. This will be the key of my mapping. So bids, my mapping variable, then between square brackets msg.sender equals msg.value. msg.value represents the wave value that that account has sent. Now let's deploy the contract. The contract has been deployed, and from the first account from this list, I'll send 50 way to my contract by calling the bid function. The function has been called. From the second account, I sent 90 way to my contract, also by calling this function. The transaction has been mined and the function executed successfully. And now I want to see what is the value of this key, so of the first address in the mapping. So here I paste the address and I'll get the value that address has sent. If I want to see the value for this address, I copy paste the address here and I see the 0 value. Why is the 0 value here? Because this account, the third account, didn't send way to my contract. If that account would send some way, let's say 59 to my contract, then here the corresponding value of that key will be 59. I said before that if we want the value of an unexisting key, we get a default value. Let's take another Ethereum address. This address hasn't been added to the mapping, so this key doesn't exist. I copy the address, I paste it here, and we can see that the corresponding value for that key is 0. So we can imagine that inside this mapping there is any possible key with the default value, of course, if that value wasn't modified. This is how mappings work. We'll use mappings a lot in our next examples.